Now we're going to look at the domain and range of functions. So first of all, consider a function y equals f of x. The domain of the function is the set of all values of x for which the function is defined. For example, a lot of the functions that we use are functions from the real numbers onto the real numbers. So for a function like that, the domain is the real numbers. So that's the entire number line. That thing that we define the function as being onto, that is called the codomain. You might have heard this previously called the range, but I'm not going to call it the range here for reasons I'm about to explain. So when we define a function, we say it's a function from the domain to the codomain. Pretty much all the functions that we use in this class are from the real numbers onto the real numbers. So that's the entire number line. So you have your x-axis number line and your onto your y-axis number line. For example, look at the function y is equal to x squared. That is a function from the real numbers to the real numbers. So the domain is the real numbers. You could also write that as this interval from minus infinity to positive infinity. That's another way of saying the real numbers. The codomain of that function is also the real numbers. If we plot this function, we don't actually get, if this is x and y, it looks like this. So the negative y-axis isn't used at all. So the name that we give to all of the values that y actually takes is called the image of the domain under that function. In this case, the image is all of the positive real numbers, or non-negative real numbers actually, because 0 is included. For the purposes of this module, that thing, the image, the set of all values that y actually takes under that function, is what we call the range. In different textbooks and stuff, the range sometimes means the codomain, and it's sometimes in other books means the image. So just to make it clear from the outset, for this course, when I talk about the range of a function, I'm talking about the image. That is the set of y values for which there is some f of x equals y, or the set of y values that the function actually takes. So for our purposes, the range is the set of all y values that the function takes. So in set notation, that's the set of all f of x such that x is in the domain. A definition of a function is that it's just a rule which associates exactly one element of the codomain with each element of the domain. So that means there is one and only one y value for every x value in the domain. If I have a function and I want to find an inverse function, that is a function where the domain and range are swapped and you go backwards. For example, if f of x was equal to 5x, the appropriate inverse function, f inverse of x, would be equal to 1 over 5 times x. So if you put in a y value from f of x, you get back your original value. So for example, f inverse of f of x is always going to be equal to x, right? It's the function that goes backwards, or the inverse function. Now, in order to have an inverse function, it has to be the case that for every element of the range of your function, there must be only one element in the domain associated with it. So, for example, if f of x is equal to x squared, then f of 2 is equal to 4, but f of minus 2 is also equal to 4. So I have two elements of the domain associated with the same element of the range. And that means I can't have an inverse function, because the inverse function will have the domain and range swapped. And so then you'll have two values of the range for a single element of the domain, which makes it not a function. For example, we have y equal to 4 here. If you want to go backwards from y equal to 4 and say what was the x value, you don't know what it is because it could have been 2 or minus 2. So in this case you can't write an inverse function. You could write an inverse function for a limited version of this function, where I say f of x is equal to x squared, but if my domain was only the positive values, so that if I plot it, it just looks like this. So this is not included. This function, where my domain is limited to the positive values, that is this domain, that does have an inverse. Whereas the version where the domain is the entire number line does not have an inverse. So the next thing we're going to do is look at the trigonometric functions, sine, cosine, tan, and we'll see that since they take the same y value for many x values, we can't write an inverse. But what we can do is restrict the function to a limited range of x values, and then we can write an inverse for that limited function.